Maptek Evolution is a unique open-cut scheduling tool. It holistically schedules material from an open pit while simultaneously directing that material to the most appropriate location based on cost minimization and considering other geometrical and practical constraints. Why is this important? Well, mines are getting increasingly deeper, costs are getting higher, strip ratios are increasing to a point where in some cases, operations have become waste mines. It is not uncommon for the haulage costs to account for between 40 to 50% of the total unit mining costs. Hence, the ability to change this early in the mining schedule will have a positive impact on the net present value. Most systems work on the following parameters. Schedules are based on material movements. At best, haulage estimation is based on bench centroid to dump lift centroid and is calculated after the fact. That is, once the material movement schedule is completed, the truck fleet can then be estimated for each period. However, there is now a disconnect as the required truck count is likely to be different to the original starting point. Secondly, the final landform shape is typically not optimized and requires either trial or error to get it right, or the use of a specialist software or consulting approach to complete this task. Thirdly, the result is just an estimate as the landform shape lacks the granularity necessary to get good quality results. Finally, the destinations are predefined. That is, this material is going to a set location. There is no opportunity to search for an alternative. All of this means disconnected workflows, processes, software solutions and vendors, as well as approximations, poor assumptions and guesses, are hardly a way to run a mine or model truck fleets where the costs can be in excess of $5 million per unit. So how does Maptek Evolution work? Well, in a nutshell, we use the next generation optimization algorithms together with a high performance computing environment to find the lowest cost position to place the waste while fully utilizing the equipment fleet. This approach has proven to reduce mining costs earlier in the schedule, right at the key time when you want to maximize the value of your schedule. You also benefit by deferring the purchase of the trucks. Starting with a normal mining model where the waste inside the open pit is identified as waste, material with this ID can then get mapped to certain positions in the waste landforms, or it can run unconstrained. Waste landforms are typically upside down models. They are built between two surfaces and typically contain thousands of blocks, which ensures a highly granular approach. In this case, the waste landform is made up of over 7,600 blocks. Compare this to your standard large waste dump with one or two lifts. The next step is to digitize profiles in Vulkan. Profiles are simply center lines snapped to the triangulation surface. We can differentiate between in-pit, ex-pit, and on-waste dump roads. As a comparison, we need less than a tenth of the objects when compared to other systems. For example, this model with 43 objects took 6 hours to build. The one on the right took 4 days and over 520 objects to build. Even better, because Evolution is tightly integrated with Vulkan, we can simply drag and drop a DGD file into Evolution and the whole network is built automatically. We also build a truck type to use in the scheduling process. Each truck is defined by weight and payload characteristics, as well as rim pull, retard, and fuel burn curves. These are simply imported using CSV data and can be customized for your site. During the schedule setup, we define the number of trucks, or max, lost time, plus the utilization and operational efficiency, which are factors to decrement calendar time down to operational time. In other words, the time per period used for haulage. We can even allow for the number of effective minutes per hour to be used during productivity calculations. Waste landforms can be manually turned on and off during the schedule to model certain conditions, such as the inability to dump in a location during wet season, or environmental or permitting reasons. We tag an item, such as lithology, in the model to allow swell factors to be modeled appropriately, as we end up filling the waste landform with those loose cubic meters. We can allow for auto precedence controls as well, by coding the model with different area codes for matching certain lithology codes to certain areas in the waste dump, for example, encapsulation. Finally, we use haulage costs or ratios to determine whether we should haul up or out to determine the next least cost position to place the block of waste. Fixed times can be applied together with default speeds and rolling resistances on the dump and within the pit. Lastly, evolution can work with any number of models and destinations. Now let's see it running. The first thing evolution will do is build the source destination list, which will be stored in memory cache for efficient retrieval. Every block source will be mapped to every block destination, hence this cache can get quite large. Once built, the schedule will start working, focusing on meeting the ore targets as well as the haulage hour target. Therefore, for a given schedule, evolution will fully utilise the haulage fleet and material movement will fluctuate depending on where the material is being mined and where it will end up. Once the schedule is complete, the user can load the entire schedule and visually step through each period. Individual blocks can be queried and the actual road and map will be displayed together with the productivity information for the block, including haulage hours required to move the block, average time, productivity, and location. Other numerical information includes detailed haulage order reports, as well as pivot-style reports showing by destination where material has been placed, tonnages, and hours. All of this information can be exported to Excel or as DXF files, which can be uploaded to Vulkan. Maptek Evolution has been proven to reduce the number of trucks earlier in the mining schedule, as well as reducing the overall mining costs. Maptek Evolution. Unique, holistic scheduling solutions. Planning for the most cost-effective schedules, all within an easy-to-use solution.